Okay, so thank you for watching all our previous videos. Also, like if you haven't seen our videos on astronomical instrumentation, I'll make sure that the links are on the description below. So if you haven't seen it, please go ahead, watch it. There's like a whole series on everything about telescopes. Yeah, thanks for all the support. So we have decided to extend this series to fundamentals of astrophysics. So we would like to talk about, so I just want to talk to you guys about different aspects of astrophysics, not just instrumentation. I would have briefed up a little bit from in the previous videos, so now I just want to like I just want to like go over it and like start the whole astrophysics journey. So yeah, I mean in astrophysics, like okay, it's all about stars and planets and the night sky and everything up there, right? Galaxies, quasars, nebulas, so on, right? Those are the names that comes to your head as soon as you hear the word astrophysics or astronomy, or like Big Bang, black holes, go on, right? I mean, it's just, I mean, this is where I want to like pull in like one of my favorite astronomers, Neil deGrasse Tyson. He once said, like, if you take any other field, right? Like if you take biology, the most important molecule in biology is deoxyribonucleic acid. Too complicated. In astronomy, the biggest event is a Big Bang. We like to keep things simple and easy. A red star that's massive, it's a red giant. A blue star that's super big, it's a blue supergiant. So that's how we go with it. But before I start like the whole thing with astrophysics, like, I just want to start with the basics of what you can see in the night sky. I mean, as soon as I say that, okay, hey, I'm an astronomer, the most common things that come up are constellations and so on. So let's like go over that first, and then I'll slowly get you into the astrophysics. And this is going to be a whole new series. So please do subscribe to the channel to learn more about it. So to start with, let's first look into our sky, right? I mean, not just the night sky, generally the sky. So what do we mainly see? If you just go up, sit on your terrace, look up at the night sky, what would you see, right? On your backyard, wherever you can. You would see a bunch of stars. Sometimes you'll see the moon. And at times you might see like a planet, but not many people know that's a planet or not. So I can explain how a planet works with. So how do you identify a planet? So there are like few standard things that people always say, planets don't twinkle, stars twinkle. The answer is yes and no. Sometimes planets do twinkle. So the reason why they twinkle or any stars or planet twinkle is mainly because of our Earth's atmosphere. The light that comes from these objects, they get distorted as they come down, these distortions are what that causes twinkling. And planets do twinkle, and even the moon, like the whole concept of twinkling, you can even see it on the ground. So let's say you're driving on a nice hot day on a straight stretch on a highway, you would see that it's almost like, you know, water boiling or like kind of watery effect that you see on the side. It's the same effect. Excuse me. So that's how it twinkles. So how do you identify a planet, right? So why did they name planets? It's called the wanderers. Why are they called the wanderers? The main reason is if I like look at a star, right? Like, okay, our sun is here. Okay. And we've got the Earth going around, right? So I'll just put the sun here, and there are a bunch of stars, right? So now the Earth goes around the sun, which we call one sidereal year. Now this one sidereal year actually, it takes 365.25 days, right, to complete one sidereal year. Now the whole point with this is that, like, say, okay, at any point of the year, right, like let's say tonight, you go up to the night sky, you look at the stars. A year later, you're going to see the same stars at the same position again. The reason is, well, you've done one complete cycle, and let's say you've seen like 3 stars in the night sky, you're going to see the same 3 stars on the same day, at the same point, at the same time in the night sky. So tonight at 9 p.m., if the sky is clear, you go and you see a particular star up there. I mean, it's winter now, so you might see Orion, the constellation Orion, and there's like, say you might see like the star Betelgeuse, which is a red star on top of Orion. Now, a year later, on the same date, and if you're going to see the on the same date, and if you're going to see the night sky at 9 p.m., you're going to see Betelgeuse exactly where you saw it last year. So that's the whole point with this sidereal year. Now, planets, on the other hand, they're also orbiting around the sun, right? Now, let's take Mars for example. So, like today is the 11th of December 2022. So, actually, like 3 days back, on 8th of December, we had what we call as the opposition of Mars. That is, Earth is right between Mars and Sun. It's not like, okay, sometimes they always say that, hey, it's a super rare event. It's not a super rare event. It happens once every 2 years. So 2 years later, like in 2024, you're going to see the same opposition again. So if you missed it this year, don't worry. 2024, you're going to see Mars opposition again. So opposition is exactly how I have drawn here. Like if you see the Sun, the Earth is right between Sun and Mars. So at midnight, Mars would be right above you. And there is another concept. Let me get. Okay, so there's another thing. Okay, well, before I jump to that. So now the point here is all these Earth and Mars, they go around the Sun, right? So if I go back to 11th of December night, 9 p.m. and look at the night sky, and now I see Betelgeuse. Betelgeuse is right where I want it to be. Now, if I look into, if I now look for Mars and see, is Mars exactly where I saw it last time? The answer is no, it won't be there. Now, the main reason behind it is that Mars is also going around the Sun. So basically, in the night sky, the stars tend to move, like drift westwards, as the days go by. So tonight, Betelgeuse, you're going to see it on one spot at 9 p.m. Tomorrow, it's going to shift slightly westward at 9 p.m. and the day after, it's going to shift slightly more westwards. Whereas for planets, that's not the case. It's almost like you're on a racetrack, right? You're driving your car. There are 2 cars on your side. One is Venus, one is Mars. And you're on one car here. Now, the 3 cars go in different speed depending on where you are on the track, right? So basically there might be times that you'll see this car drifting back and this car drifting forward, and this is what we call as the retrograde motions. So the stars will tend to go in the night sky east to west, right, over every night, whereas planets, they don't do it. So if you look into Mars on the night sky and you plot where it is, the position every day, it tends to go like this, then turns around, goes like this. This is what we call as a retrograde. So this is why they call these objects as planets or wanderers, because they don't go in one specific way. They go, they wander, they don't stick to the same place. Now, with that being said, I have to introduce a few more things that you need to know in the night sky. So these are few reference coordinates and how we look at the night sky. So one of the reference systems is what we call as a celestial equator. So now imagine I'm on Earth, okay, and I'm standing here, okay, I'm in Chennai. This is at 13 degree north, roughly 12 point something. I'm over here, and the equator, which is at 0 degrees, is a bit further south from me. Right now, if I can project the equator on the night sky. So this projected onto the night sky, that's what I call as the celestial equator. Now this is just like a point of reference to me. Why do I really care about it? I really care about it mainly because I need some points of reference in the night sky, right? So one of the points of reference is what we call as a celestial equator. Just basically, okay, I'm here, I look up, that's my zenith. Below me, it's called the nadir. So the point above me is called zenith, and below it, it's called nadir. And basically, now I'm at 13 degrees, right? So if I turn 12 degrees southwards, that's where my celestial equator will be. There is another thing that we call, which we call as the ecliptic. So the ecliptic plane is basically where all the planets and the stars are. Now, it's actually like a really interesting fact. If you look into the night sky and you look into the moon, the sun, Mars, every other object in our solar system, you can actually draw a straight line through them. They are all part of the same plane. Maybe like, few degrees here and there, like 1, 2, maybe 5 degrees max, up and down. They all are on one line. The reason being that when the solar system formed, or when any planet formed, they form in something called as a protoplanetary disk, which is a thin disk with dust and gas with the star at the center. So these are the disks. The disk is basically the leftover material. Why is it a disk? Because of law of conservation of angular momentum. So to conserve angular momentum, a disk is the best shape you can have. So because of that, now all the material are constricted to that disk, right? Even us, the earth, and the stuff that is made on like your body or my body, everything over here used to be part of that disk actually. Now so this is the reason why all our planets are like on the same plane. Now this plane is what we call as the ecliptic plane, yeah, that's another point of reference for us, and it's easy to find. Now constellations, right? Like these are patterns in the night sky. Now our ancients, when they look into the night sky, certain stars formed certain patterns, and these patterns kind of reminded them of certain mystical beings or some stories and drama behind it, right? Now let's take, say, Orion, for example. Orion has like 4 stars: Betelgeuse, Bellatrix, Regal, and Safe. And then at the heart you have 3 stars, which is the Orion's belt. So this is like the 2 shoulders of Orion, and that's his belt, and that's his leg. And here you'll see a fuzzy object, which is the Orion Nebula. That's the hunter's sword, the sword of Orion. Now this is easy to cap. This is one of the most easiest constellations in the night sky. This is easy to capture. Easy to observe as well, easy to visualize it. But there are a few more constellations in the night sky. Some of them are really tricky. Some can be like just 3 stars, and that can be like, a dog. No idea how that's a dog. I'll leave it to the imagination of our ancestors, but now we are stuck with that. So yeah, coming back to this, now I was talking about this other plane, right? Now this plane is where all our planets and moon and everything are. Now the constellations that are on this plane, on the night sky, right? The constellations on this particular plane are what we call as the zodiac constellation. Aries, Pisces, Libra, Cancer, Virgo, everything, they all fall under that one particular plane, and that's what we call as the zodiac. Now, that being said, now you understood like the basics around what is in the night sky. How do I look at the night sky? Now, also there is like one point of reference, which is our north, right? So in the north, I should be able to see one star that's always fixed over there, and you would have guessed it, it's the pole star, Polaris. But is Polaris the absolute true north? The answer is no. there is something called as NCP, the North Central Point. So what happens is, we've got the Earth that spins around west to east every day. The Earth spins around west to east every day, and in the north, right on top, you've got the star Polaris. Now, Polaris is like basically you have, it spins on Earth on the axis, right? So let me just draw it again. It spins around on an axis at an angle of 23 degrees roughly. So that's what we call as our axis tilt, right? Sorry about my drawing, but yeah, that's the axis tilt from the main central thing. So let me draw the Earth again. Excuse me, sorry about this. So we've got the main axis and it's at a tilt. And our Earth spins around west to east once every 24 hours, right? Now, at the top of it is what we call as NCP, the North Central, wait, not here, NCP, the North Central Point. Now, this is where you've got Polaris just a little bit off from the NCP. It used to be at the NCP few centuries back. And why did it change? It's a thing that we call as precession motion. Now, precession motion is basically, you would see precession, say, when a top is spinning. So when a top is spinning, you would see like the top actually spins and it holds its place. But after some point, it starts wobbling around and it starts moving around. And this is what we call as the precession motion. So even Earth's axis also wobbles around a little bit. Okay, it wobbles around. So right now, say we've got Polaris on one point, and I think in another 20,000 years or so, we will have our axis would be somewhere here on another star called Vega. So this is like Earth's precessional motion. And yeah, the Polaris, the pole star is on the top, but that's not the absolute point where our axis points right now. It points to a little bit off from Polaris. It's called the North Central Point. So now I've explained to you like basics of the night sky. Hope I've covered everything. Now these are just like certain facts that I just wanted to drop. But now let's come to the other fun parts, right? Now this entire series I'm going to talk about cosmology and how the universe formed. Where are these different stars and stuff? Right now these are at super huge distances. I'm bad at remembering numbers. Like super big numbers, no, I'm really bad about it. So how do I remember all these things, right? Now in astronomy we have a lot of different units. So one is a light year, which is pretty famous. Any Star Wars fan, they would have they also know about another unit called parsec. There's another one called astronomical unit. And of course, like we've got, at times we use kilometers, but not that often. So light year is the distance that light takes to travel for 1 year. So this is actually one of the most fascinating units in astronomy. At least I find this unit fascinating. The reason being that for this distance, light takes 1 year to travel, right? Now, the nearest star to us, Alpha Centauri, is about 3 light years away. That means light took 3 years from Alpha Centauri to reach me. Now, that's the fastest speed in the night sky. Now, if I'm looking at Alpha Centauri, I'm basically seeing that light that left Alpha Centauri 3 years back, right? So basically I'm looking at Alpha Centauri, how it was 3 years back from now. So that's the most fascinating part about this unit light year, because now tonight, even if you take the sun is 8.5 light minutes away. So what you're looking at is not how the sun is right now. It's how the sun was 8.5 minutes ago. So there's like a famous thought experiment that Albert Einstein did. There's one famous thought experiment that Albert Einstein did where if the sun is about to disappear right now, right, it would take us about 8.5 minutes to actually know that the sun has disappeared. So, like, how do we then get to know about it, right? So then what would happen on a gravity perspective? So that was a thought experiment that Einstein did. So if you look at the night sky is basically a history movie. It's a movie of history. So I'll just quickly go over the rest of the units. So light year is that one. Parsec is the distance for an object. So basically we measure by parallax. So parallax means sometimes you stick a thumb, you open and close your eyes, you see your thumb moving left and right, right? So the angle, the parallax angle that it makes for your eye, if it's like 1 arc second, which is 1 over 3600 of a degree, the star that has a 1 arc second of parallax, that's what we call as 1 parsec, which is about 3.26 light years actually. And then we've got 1 astronomical unit. So an astronomical unit is the distance between Earth and the sun. So that is 1 astronomical unit. Mars is about 2.2 astronomical units. Venus is at 0.8 astronomical unit. So astronomical unit is something that we use within a solar system or any other planetary systems. Now parsecs, we use it on a galactic level, and light year is more intergalactic level, and this is between galaxies also. We use parsecs and megaparsecs. So keep in mind with all these units, and for now I'll close this video. In the next video I'll go into more detail about cosmology, where we'll be talking a lot about all these units. So see you on the next video.